Okay, in this video we're going to continue with finding the derivative of just 7 through 10 here. So on number 7, we're just starting with e to some power. So the first step to finding the derivative of this is to copy that down. The derivative e to the x is e to the x. So we keep it exactly like it is. So that's going to be e to the sine of 2x. And then we need to chain the derivative of the exponent. Well, the exponent, we actually have a composition of functions in the exponent. It's sine of 2x. So I'm going to actually have to do a couple of chains here. The first chain would be to multiply by the derivative of the outside function of my exponent, which would be the derivative of sine x. So that's going to be cosine of 2x. And then I also need to chain the derivative of the inside part of that, which would be 2. So we have a couple of chains on that one. Number 8 is a product. We've got two functions here, e to the mx and cosine of nx. Now it looks kind of complicated, but just think about m and n as being constants. So treat those as though they are numbers, and how you would do the derivative of those functions if those were numbers. So I do have a couple of functions multiplied together, so I'll do the product rule. So y prime is equal to the first, so that's just e to the mx, times the derivative of the second. So that would be the negative sine of nx, but then I have to chain on an n, right? So if that were like cosine of 3x, I would chain on a 3. So I'm going to keep that as n. I'm just going to chain on that n there. So the first times the second plus the second, which would be cosine of nx, times the derivative of the first, which would be e to the mx, chain on the m, right? Because the m could be a number there that we would need to multiply by the derivative of the exponent there. We need to chain that on. Okay, so again, looks kind of complicated, but anytime you just see a generic constant there, treat those as though they are numbers and how you would handle those. Number 9, we have natural log of cosine of 5x. So when we do the derivative of natural log, the first step, what I always do when I have natural log on the outside is I'm just going to say 1 over whatever I have on the inside, so cosine of 5x. And then I'm going to chain on the derivative of the inside of the natural log, which is the cosine of 5x. So I need to chain on negative sine of 5x. But then again, I still have another function on the inside of that, so I still need to chain on a 5. Number 10 is, hopefully it looks a lot different. Number 10 is implicit differentiation is what we're going to need to use here. And that should jump out at you whenever you have a bunch of x's and y's that are multiplied together. Your function is not written as y equals. You're not going to be able to manipulate this to make it y equals. So we're going to use implicit differentiation. And it's going to get a little bit complicated here at the start because we need to use a product on both of the first two terms. I need to do a product rule. So the derivative of the first part, x, y to the fourth. Product rule, I'm going to do the first times the derivative of the second, which would be 4y cubed. And then remember, with a y, you chain on the dy over dx. So the first times the derivative of the second plus the second, which would be y to the fourth, times the derivative of the first, which would just be 1. Okay, so that's the derivative of that first part there. Plus, I need to do the derivative of the second part, which is going to be, again, a product. The first times the derivative of the second, derivative of y would be dy over dx, plus the second times the derivative of the first. So that's going to be y times the derivative of x squared, so that's going to be y times 2x. So I'm just going to write that as 2xy. And then this is going to equal, I'm kind of running out of room here, the derivative of x, which is just 1, plus the derivative of 3y, which is 3 dy over dx. Okay. After you take the derivative of each individual term, remember your goal is to get all the dy dx terms on one side and everything else on the other. So I'm going to keep my dy dx terms on the left, which means we are going to have this term on the left, this term, and I'm going to subtract that term over. I'm also going to rearrange this first term to make it look a little better. So I'm going to say 4xy cubed dy over dx plus x squared dy over dx. And then I'm going to subtract, again, the 3 dy over dx. So minus 3 dy over dx. Everything else is going to go to the right side of the equation, so the 1 is going to stay over there. I'm going to subtract the y to the 4th over. And I'm also going to subtract the 2xy. Your next step is to factor out the dy over dx on the left side, because every term over here has a dy over dx. So I'm going to do that. And then remember, after you do that, you're going to divide by everything that was attached to those dy over dx's. So the numerator is going to be what I have on the right side of the equation, which is 1 minus y to the 4th minus 2xy. And the denominator is going to be these individual parts that were, again, multiplied by dy over dx. So that's going to be 4xy cubed plus x squared minus 3. And that would be our derivative using implicit differentiation.